Welcome to the Head Shepherd podcast. I'm your host, Mark Ferguson, CEO at Next Gen Agri International, where we help livestock managers get the best out of their stock. Before we get started, a big thanks to our three fantastic sponsors. Allflex, part of MSD, perhaps better known as Cooper's Animal Health in Australia, offers one of New Zealand and Australia's largest livestock product portfolios with a comprehensive suite of animal health and management products. Heininger is a one-stop shop for wool harvesting and animal fibre removal. The Heininger team have a deep understanding of livestock agriculture, backed by Swiss engineering and a family business dedicated to manufacturing the best. ProA Livestock Equipment have been delivering industry-leading livestock handling systems to producers across Australia, New Zealand and beyond for the last 25 years to improve on-farm safety, efficiency and profitability. We are grateful to our sponsors for their support, helping us bring Head Shepherd to you each week. And now it's time to get on with this week's episode. Welcome back to Head Shepherd. Great to have you listening along. You're with Ferg as usual. This week on the show, we feature Dan Garrick from Helical. Helical are a business that handle both databasing of genomic and performance information across lots of different breeds and species across the globe. And they're signing up new breed societies all of the time, as you might see if you follow them on social media. They also run a software program called Bolt, which is actually genetic evaluation software and single-step software handling genomics and performance information, a range of different businesses and breed societies using that business. So a really good chat with Dan. He's second-generation geneticist, comes from an aeronautical engineering background, almost a rocket scientist, and then followed his father's footsteps down the genetics and genomics line. So a really interesting chat with Dan. Before we get into that, I wanted to mention a couple of precision productivity and profit workshops that we're running at Pudgenook. There's 4 Ps all in a row. So on the 25th of May, we'll be at Pudgenook in the afternoon running that workshop. It's a 4-hour workshop covering the use of sort of EID and, I guess, using precision in sheep production. It's a workshop as part of the Precision Sheep Management Project that we're running on behalf of AWI and MLA. And in conjunction with Murdoch Uni, Adelaide Uni, Deep Herd and WA, and a range of other groups that are sort of collaborating on that project, including Next Gen Agri. But this is a couple of pilot workshops. So one at Pudgenook, 25th of May, another one at Charlton on the 2nd of June. And all those details are on the hub. The hub.nextgenagri.com is where you find them. Go to the events section there and sign up. It is necessary to register your interest if you are going to come along, or flick me an email if you're interested. Yeah, 4-hour workshop covering how to get the most out of EID or focusing on a data plan and really drilling down into the things that matter to you most. So 25th of May, Pudgenook in the afternoon, 2nd of June, we'll be at Charlton in Victoria in the afternoon as well. So if that's of interest, by all means, jump on and register and get some more information at the hub. Righto, we'll get underway with this week's show with Dan Garrick. Welcome to Head Shepherd, Dan Garrick.
Thanks for having me.
Awesome, mate. Been looking forward to this chat. Helical doing great things. Keen to get into the detail of all that is Helical these days, but before we get into that, really keen to sort of understand your background, which isn't, well, it's not that many people that can be claimed to be second-generation geneticists, so maybe third. I don't know if there was one before Dorian, but yeah, I guess maybe a bit of your background growing up in NZ, but then ending up with a PhD in aerospace engineering.
Yeah, so I grew up on a sheep, beef and venison farm in Colliston and Manawatu, so Lower North Island, and about 80 acres. And went to a school of about 100 kids, so very rural. And my old man Dorian was a professor at Massey University in animal breeding and genetics, and he got a job when I was about 13 or 12. In the US at Colorado State University. So we moved over there, and I effectively did my high school and then went on to do university over there as well, which my undergraduate and PhD were both in aerospace engineering. But I've been working in the genetic space since beginning of 2017. And I guess my dad's dad, he was a ichthyologist, which is so he had a PhD in zoology, effectively. Basically, ichthyology is the study of sharks. So he was one of the world's foremost experts in a variety of sharks, including the great white. And yeah, so we were three generations of PhDs at least, but which is pretty cool. But yeah, he wasn't a geneticist, but yeah, all about sharks.
I'm sure he probably spent a fair bit of time thinking about genetics if he was playing in that field. So that's very cool. I guess going from heavy engineering into genetics seems like a bit of a leap. In fact, it's all maths. Is that sort of how you approached it? Or?
Yeah, basically. So, I mean, it seems like it might be a stretch to understand how rocket engines or aeronautical engineering would tie into genetics, but yeah, fundamentally the same maths that we use to design or model in aerospace, so model fluid around aircraft to design aircraft or rockets or any of those types of things, the same mathematical methods we use to generate breeding values. Is basically the crossover. So, a lot of maths, a lot of programming, and solving equations using computer software. So the equations are obviously quite different in terms of the applications of those equations, but fundamentally, yeah, solving equations on a computer.
Yeah, exactly. You've already mentioned Dorian, your old man, and one of the more respected figures in animal breeding, certainly in New Zealand, but globally. I guess, yeah, what's it meant to sort of work alongside him over recent years, and I guess has he shaped sort of how you've approached things?
Yeah. I mean, I feel very fortunate to be able to work with him. It's certainly not something everyone gets to do, and I'm lucky that we've got a good relationship as well. So yeah, it's been really cool to be able to work with him. I mean, I always kind of joke that the extent of my genetics training really is actually a class I took. I think it was my first year in the US, or maybe my second year, where it was about 13, and I took a biology class, and there was a section on genetics. And I think, technically speaking, that's the extent of my formal genetics education. And the rest is all just purely osmosis from just being around Dorian my entire life. So obviously, I've had a bit of a crash course in genetics over the last almost 10 years now working with him. So very much, have done more in that space than in aerospace by this point in time. But it's a lot of fun. It's unique. He's very academic focused. So sometimes that's where I'm probably a bit more commercial focused and have a bit more of the commercial eye around how, we can create business models around things. And he's very much, the academic and the science and, all the development. And I really look at, how can we bridge that science and that research, that academic research, into practical tools that we can actually deliver to people.
Yeah, which is a great combo. Obviously, you need both those sets of skills in a business like that.
Yeah.
So, today Helical's the sort of business we get to see. But before Helical, you built Bolt, whether it was you or both you and Dorian, not sure. It's now sort of underpins some big genetic evaluations, including IGS, I think. I guess back then that was, I think, one of the first or the first single-step evaluation, and so combining phenotypes, genotypes, and pedigree into one analysis. I guess maybe just talk us through what it does, why that matters, and sort of what step change that achieved.
Yeah, so the origins of what we call Bolt. So I guess to take a step back, so we really have two software products. We are a software company at heart, and we've got two products. And one of those products is what we now call Helical, which is the database system. It's the foundation, if you like, of all the storage of all the data, so pedigree data, performance data, genomic data. But that product was born out of a need that I identified once I started working in the genetics space, and that was when I first joined the company back in 2017. That was really right at the start of us finalizing production single-step evaluations for a number of customers using Bolt. And so Bolt is our other product, and that's all around, like you said, single-step evaluations. So combining pedigree data, performance data, and genotypes to produce breeding values. And the origins of Bolt actually go back to the 80s, believe it or not. So there was a piece of software before Bolt called ABTK, the Animal Breeders Toolkit, that was developed at Colorado State by Bruce Golden and a couple of other geneticists. And that was used, quite widely to roll out pedigree-based evaluations back at that time period. And Bolt was the continuation of that to be able to leverage a couple of things. One, the DNA data, and the second thing is we leverage within Bolt what we call graphics processors. So effectively, kids' gaming computers, they've got graphics processors in them to drive all the video, the graphics generation, and graphics processors are also what power all of the AI models that we're all using today. ChatGPT, those are trained on graphics processors, so it's a special type of computer hardware, effectively, to crunch lots of numbers. Is the short version of it. And so we've been leveraging that technology since early 2014 when Bolt first started getting developed by Dorian and his colleague Bruce Golden. And that's sort of when I started to. So I was in the last sort of couple of years of my PhD. And I started to assist Dorian and Bruce with sort of setting up some of the servers and the computers. I'd built a few gaming computers over the years, so I helped them sort of build some of the computers they were using to actually set up these single-step evaluations using Bolt. And that's when I actually started to realize that, the things that my dad worked on were not too far different from aerospace engineering, and actually kind of understood it, and it looked pretty interesting. So by the time I finished up my PhD, they'd got enough business on in terms of selling Bolt to different customers to be able to hire on someone new. And they asked if I was interested, so I joined the company. And one of the first things I ran into as we were, beginning of 2017 is when I joined. And they had already been working for the last couple of years, sort of developing and productionizing a lot of the methodology and the algorithms to be able to run single-step evaluations routinely. And they were working predominantly at that time with two organizations, one being IGS, which is really the American Scimitar Association underneath, and then the American Hereford Association to roll out single-step evaluations for them. And so I kind of joined on and started working and, getting those over the line. And both of those evaluations, well, American Hereford got it released, I think, late 2017. I think December 2017 is when I went live. And I think IGS went live a few months later in early 2018. And in any case, one of the first roadblocks we ran into rolling those analyses out was actually nothing to do with the evaluation itself. It was just the storage of the genomic data and the management of the genomic data and the processing of it to get it into the evaluation, and to do that on a routine basis, because both of these evaluations we were targeting to run them weekly. So every single week, the analysis would run end to end, incorporating all of the new data that has been accrued over the prior week. And that obviously requires a pretty robust set of data systems to get all that data into the analysis. And very quickly, we recognized that was the biggest bottleneck, was the genomic data. There was no systems out there that could store it. All the database systems that existed to date were really focused around pedigree data and performance data, and largely no one had really solved the problem. There were a few tools out there, open source tools or academic tools that people had built to kind of deal with aspects of genomic data, but there was nothing that you could just go and buy off the shelf like Microsoft Office to manage your genomic data. So that was one of the focuses of mine, sort of that first year, to get American Hereford live, and with their weekly evaluation. And very quickly after we rolled that analysis out and released it to people, we started getting contacted by other organizations who needed to manage their genomic data, predominantly breed societies, but not just breed societies. And actually one of them, probably the second or third even, who reached out to us would have been Carl Tesling, who I think's been on the podcast previously.
Yeah.
And he was working at Australian Wagyu Association at the time. And, they, like many societies, had just or were in the process of changing their society bylaws to require DNA verification in order to register animals. And there was this evolution from microsatellite technology, which is a prior version of DNA technology, to SNP testing, which is what we mostly use today. And the data systems just haven't kept up with that evolution in technology, and so that was the niche that we found ourselves in, and very quickly it grew rapidly, and it has evolved over time, obviously now into Helical.
Awesome, yeah, that's a really cool story of how it all came about. I guess just for those out there who haven't had to play with, and I haven't either. Well, I tried to download some DNA data a few times, but yeah, I guess is it all storage problems, compute problems? Why wasn't it being solved? I guess what was left on the table? It was just the sheer enormity of the data set.
There's multiple parts to it. One of it is definitely the size of the data set. So when we're talking about 100K profile, which is one of the sort of main ones on the market these days. What that means is for every animal or every genotype sample that's collected and sent to the lab and the data is delivered back, there's effectively 100,000 data points on that one animal. There's actually more than that because there's multiple different versions of the SNPs, and then delivered with the SNP data is actually a whole bunch of other data for every single one of those SNPs. But yeah, suffice to say, it's a lot of data. So if you've got 100,000 data points on one animal, and that's maybe fine for 1,000 animals, or maybe even 10,000 animals to build something that can deal with that. But when you start getting into the hundreds of thousands of animals being tested on that kind of technology, the data volumes grow massively. And so, but that's only one part of it. So the other part of it is actually having that data automatically be delivered and ingested into that system from all the different DNA testing laboratories. Also being able to have tools that can then make use of that data for parent discovery. So that was one of the other pieces that we enabled. And then finally, to process that data and to deliver it to a single-step evaluation that might be running weekly or monthly. So any one of those parts, maybe is reasonably simple, but you kind of need it to be able to solve all of those things, or any system that's in the space really needs to be able to do all those things to solve all the problems that people are having. And so that was the, I think, unique aspect of what we did, given we started on the evaluation side and we really knew we were already doing parentage within the evaluation as a quality control for ensuring that genotype data that was coming in was, high quality to produce the most accurate EBVs. So we'd already kind of dealt with that, and then being able to process it and deliver it to the evaluation again, we'd kind of solve that. So it was really more around surfacing some tools and some web interfaces for people like Carl and others at the breed societies to be able to then manage that data and deal with stuff on top of it. And yeah, like I said, it's a sort of a niche within a niche almost. I think the selling point for us has really just been the fact that we've, really sat down with our customers and looked at what are their pain points on dealing with all of these different things. And we've built tools to specifically target those pain points and really allow them to, get the value out of that investment in the genomic data that they are making through parentage and all kinds of other analyses that they're wanting. As well as, I think the other big selling point that we had in the early days, I think it's definitely still relevant now, maybe even more relevant now than it ever was, is the ability for us to ingest genomic data from multiple different DNA testing providers into one place so that you can use all that genomic data yourself without having to rely on the service providers to do things like parentage and other aspects. It all comes to one place, and now you've got control of it, you've got full ownership of it, and you've got all these tools available to run parentage across animals who are tested at multiple different genotype providers. It's always one of the challenges for those people who are looking, they've historically always tested with one DNA testing provider, and then they want to switch to another one. And all of their ancestors, all their sires and dams going back are stuck with that provider, and to get them to share that data with another lab can be done, but it can be challenging and sometimes expensive. So the easiest solution now is to have all of it all the historical data come into Helical. You start using a new lab if that's what you want to do, and you can then run all those analyses yourself in a much more efficient time frame.
Yeah, having had a number of clients in that little conundrum of trying to swap, but being very difficult. So great concept. Just completely off topic, but being one of the earlier users of GPUs and understanding what their power was going to be, did you invest in NVIDIA when you can buy them cheap?
I did, not nearly enough. That's all I'll say. And in hindsight, it was such an obvious investment because I was actually using GPUs as well when I was doing some of my aerospace modeling. It was with the power of it to crunch huge, large volume, large amounts of numbers effectively was pretty obvious early on, and the moat that they have, and I think still have, is pretty unbelievable. It's probably still a pretty good investment if you're looking at a 10, 20 year horizon.
Yeah. No, yeah.
It's not investment wise, by the way, but
but certainly in hindsight, I certainly, having heard from your dad and our AI engineers and stuff, should have definitely invested a long time ago. But anyway, one of those things. I guess, Helical now serves, I don't know, lots of breed societies over lots of different countries across beef, dairy, other species. I guess, you've talked through what it does, but what's that growth trajectory looking like as a business? Is it, obviously it continues to grow quite quickly. There seems to be announcements fairly frequently coming out onto LinkedIn and other places.
No, it's I'd say we've hit a real inflection point in the last 6 months, and it's been insane, to be honest. And it's very, very exciting. It's interesting from the perspective of being a completely bootstrapped company. So we're completely profitable, have been from day one, no debt, no outside investors. And Dorian and Bruce are both effectively retired from the company. So I, basically running the company myself, and it's gone from just a steady trickle over time to literally about 6-7 months ago, just a vertical trajectory. And I'd say the announcements we have on LinkedIn are really only the tip of the iceberg in terms of what we've got bubbling under the surface at the moment. And I think the announcements over the next 6 months, if all goes well, will be some of the most exciting ones, I think. But we're and I guess to put it in perspective, for many years, we've sort of had a few hires, and people worked with us for a few years and then moved on for various reasons. But predominantly, we've sort of been 3 to 4 to 5 people in that kind of range. But really, over the last 2 to 3 years, we were really only 3 people full time, or 2 full time people plus Dorian being somewhat part time, I'd say. But in the last 6 months, we've hired 5 people. So, and being a bootstrapped company, we can only really do that when we've got the cash flow and the committed business coming in. And, in the ag space, the sales cycles are pretty long. It takes a long, you can be talking to people for a long time before you actually get that commitment and the signed contract and the invoices going out. That speaks to, I guess, the growth trajectory that we're on. But it's a very exciting space to be in, and it's not just, certainly within the beef cattle world alone, you look at the number of things that are happening in that space, but because all of our tools and software are species agnostic, and the inheritance, nature of DNA and genetics means we can apply it to anything that's got a breeding program, means we're getting all kinds of really exciting stuff coming in. Across agriculture and plants and forestry and sheep and horses and dogs and all kinds of things. So there's so many opportunities out there. It's crazy. It's a lot of fun.
Yeah, it's cool. It is one of the greatest things about what we do is that the principles apply regardless of what the species or animal is. It's all the principles are the same thing, which is great. So they're all functional biology, trying to use data to help work out which ones we're selecting and what we're doing with them. I guess it's obviously replacing. It's essentially disruptive technology in the sense that you're doing it more efficiently. I don't know about price point, but it's obviously very resounding very strongly with the market. And I guess Is that because a lot of the systems sort of did have to come through that evolution that weren't sort of genomics native, and so therefore had to try to adapt and just couldn't at the pace that you could?
Yeah, I think that's definitely part of it. Again, I think also because it is sort of a niche within a niche, in terms of how unique this type of data set is, and really I think one of our main strengths is the fact that we do run and develop genetic evaluations and that software for people as well.
Yeah.
So we have a really good understanding of how the database needs to be structured and set up to enable the evaluation, even if people don't end up using Bolt or our evaluation software and they're using other providers, which is totally fine with us. We're not offended by that. But having that understanding really, I think has empowered us to do a lot of things that, if you just go out and you get a software company and hire a bunch of software developers to teach them, all the aspects of what you need to know around genetics and genetic evaluations when you're designing that database system is one thing. And then you add on the genomic data management and everything in terms of exchanging that data with the labs and what's required there is a whole another thing.
Yeah.
And then you add on, when we talk about breed societies, all of the business logic and rules and business processes and how breed societies function as a business and what their requirements are around, memberships and registering animals and all of that stuff. That's a whole nother can of worms.
Yeah.
You put all those three things together and it's like just about an insurmountable moat, really. And that's what we've seen historically, is that there has been a few providers in the space and they have built a big moat because they were able to provide all of those things to people. But yeah, I would say the systems on the market predominantly were built in a different era or for a different era of data. And the cost realistically, those systems need to be completely rebuilt from scratch to properly have the right architecture to deal with all the genomic data coming in, but also all the other data, the tsunami of data that's coming in across, wearable technologies and camera systems and AI and all the different things that are allowing huge volumes of automated phenotype data collection as well, and being able to integrate the system so that data doesn't need to be double entry. Ideally, nobody's ever having to manually enter any data into any system. It's just all flowing through from all these other devices, and that's an architectural aspect to the software that when those other software platforms were built and designed, it wouldn't have been really on the radar to be thinking about that. So to redevelop a new system from scratch is very hard, and we've been grinding away at this for almost 10 years now. Like I said, since 2017 is when we really started building the data system and recognized that that was the biggest bottleneck to being able to take advantage of all these new data sources and technologies, and to being able to roll out new breeding values, fundamentally getting the data out of the existing data systems to be able to run the breeding values, and then having a place where we could put the results back in was always the bottleneck we were dealing with. So it became clear pretty early on that to really accelerate the speed at which we can do things, we needed to solve the data system problem.
Yeah, exactly. How much of that moat was compute? I guess a lot of these places needed a massive computer. Now you can dial up as many computers as you like in the cloud. That obviously changes the game a fair bit as well in terms of access to way cheaper computing.
Yeah, so I think there's two parts to it, and you really need to separate the genetic evaluation as one independent part of this bigger system from the data system where all the raw data is being stored. So the evaluation softwares, I think, have more, by and large, kept up with the science and the times and the compute. They've all been able to do more, and they're able to be upgraded independently of the data system. And but the data system is really the plumbing, right? It's the plumbing that's flowing all this data around and getting it where it needs to be, and trying to, as I said, replace existing plumbing while you've got a whole bunch of water flowing through it effectively has been sort of some of the challenge of, I guess, the incumbents. And yeah, we've just really done it in a iterative but very quick process. I mean, over 10 years, but
Yeah.
it has been very, very, very iterative where, we've solved these parts and we've just been amassing up over time. And I mean, to be fair, like the original system that I built in 2017, it was not what Helical is now. That was a pretty relatively basic system, really. It did what it could do, but I knew even in the very beginning it wasn't going to scale forever. And basically what happened and when Helical itself was actually born was sort of 2020, 2021, when I kind of was looking at not just the valuation side of things and also the requests from our customers around wanting more modern registry systems and things like that, but also just the development in the DNA testing technology side of things, which is there's just a whole lot of stuff going on in terms of the development of sequencing technologies and other things happening in that space where I was like, okay, we need to sit down and have a look at where all of this stuff is going and make sure we're prepared for the next 10, 20, 30 years to deal with all this data because it's coming. And so I basically sat down really over COVID in New Zealand and said, well, if we were to design a completely new system from scratch that could do everything we were doing today and do everything we're going to need to be doing over the next 20 years, what would it need to look like? And how can we build it in a modular fashion so it can be species agnostic, but also, we've got different customers who have existing data systems, and particularly when you're talking across different species and different company types, breed societies are not our only customers. We've got genetics companies and genotyping laboratories and universities and all kinds of things that use our systems. So how can we make the system as modular as possible to be able to deal with all these different use cases? And so, yeah, we completely redesigned a system from scratch. I hired on a developer, sat down with them, and yeah, that was sort of the first iteration of what was Helical, and it's come a long way in 5-6 years. And I can tell you, even on some of the modules in there that we built, so we built like a registrations module, I guess, for dealing with the registrations of animals. And we thought that was going to be really flexible and really configurable to deal with all the different things we thought breed societies, from what we knew about what they were doing on that front. And then it was fine for the first one or two societies. And then you get to a new society and they're like, oh, we've got this registry rule that does this, this. And we're like, oh, that doesn't quite slot in what we've got. And we'd have to rebuild that entire module from scratch to be able to do what our existing societies did, plus now handle for some other, newer types of custom registration rules. So it has been, a long road. And we're just really fortunate that we've, I think, been trying to plan ahead and look at this entire area at a systems level, I think. And I think that's one of the things that from my engineering background and training is taking a look at the bigger picture and having the situational awareness to see like what are all these different parts and how does it all need to fit together into this, complicated system, while also keeping the tools simple for our users, because the vast majority of our users are non-technical, don't have necessarily even a science background or genetics background, and need to be able to manage this data to be able to do stuff. And yeah, that alone is a challenge as well. So there's just a whole manner of different things that just make it a really, really hard problem to solve, really.
Yeah. I've only, literally the last couple of weeks interact with your UI. Is that a new thing in terms of, so some breed societies putting that or displaying that data via, I assume, via your processes? Is that's been part of it the whole way, or is that adding on a user interface as a new thing? Or?
Yeah, so we've always had an interface, even going back to the very, really, I think actually the first interface I built was for Carl at Australian Wagyu back to 2018. It was when I put some plumbing around some of the sort of back-end systems we had so he could run parent discovery. But the interface I guess I'll rewind back maybe 2 years. So the first registry that we actually rolled out was for Summertool New Zealand. So they were the first ones that came on board, and that was really motivated by them wanting to move to IGS to partake in the IGS analysis.
Yeah.
And so we were able to get things up and running for them. And so that was where we kind of finished out, the bare minimum really of what we needed to get a society on board in terms of having a public animal search and a public EBV search and sales catalogs and some of those aspects. But yeah, we'd been dealing with all of the other parts of it. There's really three layers to our system, I guess is the way I'll describe it. There's what I'd call an administrative portal, which is where the breed societies or the data managers, can access, and they can access all the data across the entire system, their system. And then there's what we call like the portal, which is an entity or a breeder portal for breeders or other parties to be able to log into, and they can only see the data on their own animals and nobody else's animals to some degree. There's public data on other people's animals you can look at, but predominantly you can only see the core data on your own animals. It's also where we surface a number of tools that people can use, like mating predictor tools, to see if I got these size and these dams, what's the expected pedigree and breeding out of those matings, what are the expected EBVs out of those matings, and the ability to register animals, to submit performance data, to export reports on all manner of data on their animals that are in the system. And then the third interface is the public interface. So that's where any member of the public, or really in the breed society space, the commercial producers can go to, and they can search, EBV criteria, find, bulls and genetics that align with what they're looking for. And there's also a place where they can view like sales catalogs in terms of which animals are for sale, and see how, again, how that relates to their goals. So all of those, so that administrative portal has been around for quite a few years, 5-6 years, probably. Really, I mean, that was there when we built the first version of Helical, because the genomic data management piece was being done through that. But yeah, all of the breeder and public portals, those are definitely more recent, relating to actually rolling it out to other societies.
Yeah, excellent, cool. You mentioned sort of having a weekly evaluation as a goal. A, have you got there, and B, when are we kind of running real time, as in I'll put in data today and expect to have breeding values tomorrow kind of thing?
Yeah. So we've been running weekly evaluations for American Hereford and IGS obviously have been as well, using our software. So there's not really a technical reason why it can't be done from for the most part. It's more around the overhead of the data system and whether the data system can facilitate it. And I guess similarly with Australian Wagyu, when they moved to Helical, they were also made the move to a weekly evaluation system, and they're not using Bolt, but they part of that I think has been enabled by the flexibility and ability of Helical to extract all of that data out on a routine and automated basis, deliver it to the evaluation, and have the results come back in to Helical. So yeah, it's just being able to have that foundation of your data system to be able to enable that type of thing. And to be fair, I don't know enough about the details of how our the other providers in the market are doing all those things and how manual or not manual their processes are. But to get to a weekly evaluation, it really needs to be completely automated, ideally, and real time. I mean, again, from our perspective, real time would be doable today. I mean, we could have a daily evaluation today for most of our customers if that was something that they wanted. For the most part, I think it hasn't been a requirement as yet. I think there's certain things that being able to do it on a daily basis would be really valuable, and parent discovery would be one of those things. But obviously, there's multiple different levels to what you're wanting results on, and the key thing is, I guess, so long as you've got the decision or you've got the results available at the time you need to make the decisions around weaning or sorting or whatever it is that you're doing, or breeding, that's the key thing. And those timeframes aren't typically daily, but there are things like with bobby calves where you actually do want a result within a day. I think we're a little ways off from being able to get things like parentage back on a bobby calf within a day, but because of the DNA testing technology is not quite there yet. But that would be where I think things will probably get to eventually. We might be 5-10 years away from that still. But
if you do, I guess, cast your mind forward 10 years, what have you got? Any? You will have thoughts, I guess. You got any you want to share about what the genetic evaluation and sort of animal data space looks like by then?
Oh, I've got lots and lots and lots of thoughts. Depends which part you want to talk about. I mean, I think there's a few things that come to mind. I think predominantly genetic evaluation historically has been more focused on the breeding, so the selection decisions around which bulls to be using, and the seed stock, or the stud market. But what we're seeing is massive opportunities in the commercial space for genetic evaluations and genomic predictions and EBVs to inform decisions that are being made in the commercial production, into all the way through into feedlots and meat processing, as far as which animals should be getting the investment in feed to finish them all the way through. So that's not a breeding decision. It is a selection decision in some sense, but it's about the genomics are informing where should your investment be. And the reality is the cost of a genomic test is pretty low relative to the marginal cost of feeding out an animal that's underproductive, and you could end up, if you've got two different animals and just looking at them, they look exactly the same. They're both black. They both weigh the same amount, but you do a genomic test on them and you can see, well, that one's got, genetic potential to finish at a much higher weight than that one. Obviously, the genetics is only one part of it, and there's multiple other aspects to it. But fundamentally, I'm kind of still shocked by the numbers of animals that are being bought and sold with just so little information behind those decisions. And it is a huge investment to grow an animal out and to finish it out, and to feed it over its lifetime. And again, when we talk about the bobby calf aspect as well, there's limited amount of feed in New Zealand to finish. We just physically can't grow out every single calf that's born and finish it. So you need to be able to make decisions around which ones are the ones that are going to be worth investing that in, and that's where I think genetic evaluations can assist as well. So that's one part of it. I think another part of it would be, I suspect in 10, 20 years, there'll be EBVs available that we haven't even thought of today. The amount of data from these wearables, from collars, virtual fencing collars would probably be one of the bigger ones, where I think there's huge potential in fertility traits and grazing time and potentially heat stress and other things that you'd be collecting some kind of correlated data from some of these devices. And I'm sure there's I know there's people who are already looking at how some of that data can help inform genetic evaluation and help inform EBVs that we already have. But I also think that there will be completely new EBVs that nobody's thought of yet, related to some of the data that's been collected on those devices. And I think that's a massive opportunity for some of those companies to look at that, and be happy to talk to any of them who want to learn more about what we got in mind there. But I think there's some really interesting things happening in that space. And likewise, there's these other artificial intelligence tools. Like I saw there was one recently that raised money to, it's basically like you take photos of animals and you get the weights predicted back on them, and it's a special type of camera with LiDAR in it, so it can actually measure kind of the 3D mass of some sense of the animal, and you get a weight back on it. But just the ability for huge volumes of data to be collected without people having to manually enter things or weigh them or do anything. It's just they walk through a race and this data is collected, and then it goes into an evaluation and helps inform it, and you get that data back here the next day or a few hours later. The potential for that is just pretty wild to think about. Yeah, no,
it's extremely exciting to think about how that can all go. And I guess, as you already pointed out, is kind of miles from where we are currently on average, although like the future's already here. It's just not evenly distributed as once stated, and that's true. Like there are examples of lots of these things already kind of in place, and what you're doing is a great example of it. At the top end of what you're doing, I'm sure there's some pretty cool stuff going down. In terms of genomics, I guess we're collecting 50 to 100k chips on most animals these days. Are we utilising 10% of that data, or are we utilising 100% of that data? Like, is there scope to utilise what we already collect better?
Yes, it's the short answer. I mean, I guess there's probably some nuances to to my answer there. I think we're probably utilizing the data that's been collected in terms of those SNPs to the degree that it's helpful.
Yeah.
I mean, the marginal difference, I mean, there's scientific debates around how many SNPs you should be using, how many SNPs you need to use to get the most accurate prediction, and there's sort of different methodologies around how you run single step and which approach is better. I think there's been a decent amount of research which has shown using more SNPs doesn't necessarily give you a better prediction. And actually that in some cases using less SNPs gives you a better prediction for various reasons. But I think there is a lot more value to make use of the predictions themselves, the EBVs. I think for the most part, whichever software or whichever methodology using behind the scenes to run single step is not a massive difference. It's not going to make or break anything. But I think the ability for people to actually take those results and use them in a way that gets the most value out of them, I think there's still a big gap there. And sort of what we call decision support tools is sort of, I think, where there's a huge amount of value still. Yeah. It's also where I think there's huge value for AI to assist in decision support. And it's not around having an AI model come in and make decisions for you around which animals you should be breeding or what you should be doing. Although I think there are people out there who are already asking ChatGPT and these AI models, here's all my EBVs and here's the data, what should I do? Yeah. I definitely know that's happening already, which is interesting. But it's more a question about how can we enable in this world where we're getting more and more and more data coming in, the ability for people to sift through all of that to actually practical decisions on farm around which animals and they should be using and breeding and so on, so that they can get better genetic gain. So ultimately what all of the stuff that we're doing comes down to. It's better genetic gain, and then, farms that are able to be more profitable and sustainable, well into the future. I think those are the fundamentals that we're targeting, right?
You've been nominated for a couple of awards recently and got into the finals of at least one of them that I'm aware of. That's, I guess, not unexpected, but it's always good to see hard work reviewed by peers and thought to be on the mark. Yeah.
So the Beef and Lamb Technology Award, we'll find out on the 20th of May, 21st of May in Christchurch. So I'll be flying down there for that. But it's quite exciting to, I guess, have some external validation in terms of what we're doing from the industry. I mean, definitely, one of our key focuses is how can we reduce the amount of time both for our customers, breed societies, but also for their customers, which would be the farmers, to spend less time putting data into systems, spending less time getting data out of systems, and to provide easy to use tools for them to make selection decisions and other decisions. So it's validating to be an honor to be a finalist in the category, and we'll see how we go. And then the other one is the NZ High Tech Awards, which we applied for a few categories there, and to be honest, I'm a little bit surprised we're not a finalist in the agri-tech category, because that was the one I thought we had the best shot at. But we ended up being a finalist in I think it's the most innovative high-tech solution for a more sustainable future, which is a very, very cool, and actually very, very excited to be a finalist in that category, because genetics has been identified as one of the biggest levers that we can pull today to improve the sustainability and improve the environmental impacts of agriculture and livestock. And obviously there's been a lot of discussion, sometimes quite heated discussion, around the sustainability and the climate impacts of farming, particularly in cattle, and how that's all measured and so on. But fundamentally, genetic gain means if we're producing more efficient animals that are producing more beef or more milk or whatever it may be, per hoof print, then we are in many respects improving the environmental impact and the sustainability of those. And then in other industries that we started to work in, like aquaculture, the sustainability takes on a different meaning in the sense that, fish and shellfish and others that are having to deal with oceans that are getting warmer, getting more acidic, and there's greater incidences of disease and parasites. And so it's actually about the survivability and literally the sustainability of some of those species to be able to survive in a changing environment as well. So I think hopefully, fingers crossed, we've actually, I think, got a pretty good shot at winning that category. We'll see how we go on the 22nd of May, 2 days later. Because one of the beautiful things about genetics is that it is really a systems level, improvement, because it's permanent and it's cumulative. It's like compound interest, right? So every improvement you make today is an improvement that's inherited by all of the generations after that. And that's just baked in. You get that for free. So that's a really powerful part of genetics. So, yeah.
Awesome, mate. All the best for those awards, and couldn't mirror those words strongly enough. I think I know we're probably both a little bit biased on the genes front, but it is, I can't see a better ticket to many of our problems in terms of cost of improvement. And if we look at where we're at today and where we could be if we were all equally using all this technology to its best ability today, how to be an insanely different industry immediately. Like, it's not like we don't need all the cool things that you'll be doing in the next 10 years to actually have a massive shift in the industry. If we just implemented what we've got now, it'd be insane. But anyway, we will.
Yeah. Oh, I totally agree. And I mean, I think this is one of the paradigm shifts that is currently happening is, genetics really has been focused on historically more on the breeding side of things, but it's now very quickly moving into more of the management side, and you're making management decisions around which animals should you be keeping and investing, the feed and other things into. And it's one of the things genomics can really unlock. But I think there's, like you said, a lot of low-hanging fruit out there, I guess is the way I describe it. And if you've got cows that are living for many years and not producing calves year in, year out, that's one of the lowest hanging fruit you can have to improve the sustainability and profitability, of an operation. So,
yeah, excellent, awesome, Dan. Often there's 10-year overnight successes, and it seems like that's where Helical's at now, and it's great to see the trajectory that you're on, and pretty excited to hear where you go next. The last question we'll ask is one that we ask everyone, and that who's the best human you've had the pleasure to learn from?
Yeah. You did give me a bit of a warning on this, but I still been racking my brain, to be honest. I mean, it's kind of an interesting one because I think, I guess I struggle to put like one single best, right?
Yeah, I got it down to 3, mate, just to give you, or 4 probably. Yeah.
I think there's all these different people you meet in your life, and they funnel into different. They give you really good advice about different things. I mean, I think maybe it's kind of cliche, but I'd have to say for me, it'd probably be my dad.
Yeah.
Just wouldn't be here if it wasn't for him. But the where I am in terms of the business and career certainly has been enabled by him taking me under his wing, so to speak, and teaching me genetics. I think I've learned a lot from him. Put it that way. I guess. Yeah, just trying to think outside of him. I think, like I said, I struggled to name one. So yeah. From just answering the one, I'll leave it at that.
Excellent, thanks, mate. Well, what is Dorian up to these days? Is he on the end of a fly rod, or what keeps him busy?
He's behind a shotgun at the moment. He's technically retired. So he retired after 40 years on the faculty at Massey. I think last year, and technically retired, but he's probably busier than he ever has been. We've got a fair bit going on across many different fronts. So he's still helping in many areas, really mostly on sort of the algorithm development and the high level technical details of someone's wanting to fit some new type of model.
Yeah.
What's required to within a single step evaluation, and what's the math required to do that. And then he develops that out, and he sort of hands it off to me and says, "Here's the math." And then I go, "Okay, how can we actually implement this into a routine evaluation system?" He's very busy, but he's taken the week off to go down to Christchurch and for opening weekend a duck shooting. So
yeah, right. Hopefully, if he's down there for a week, hopefully his liver's all right when he gets home. But,
yeah, should be. But we're off to BIF together. So that's a Beef Improvement Federation conference in the US at the beginning of June. We'll catch up with a lot of our North American customers. Looking forward to that.
Excellent. Awesome, Dan. Thanks very much for your time today. I really appreciate it.
Thank you. Appreciate it.
Thanks for listening, and thanks again to our 3 fantastic sponsors. Helical, who are proud world leaders in the manufacturing and supply of professional sheep shearing and clipping equipment. Allflex Livestock Intelligence, part of MSD Animal Health, offer an extensive livestock product portfolio focused on animal health management, all backed up by exceptional service. ProWay Livestock Equipment offer turnkey solutions from design through to professional installation and specialise in facilities that are tailored to your specific operation for all livestock species. We thank these 3 great companies for their ongoing support of the Head Shepherd podcast.